Good day, class. Welcome to our lesson for the day, which is permutation and combination under the subject probability and statistics. So first, let us answer the question, what is permutation and combination? So as it is seen on our slide, so permutation is referred to the act of arranging all elements or members of a set into some sequence or order. So in other words now, if the set is already in order, then the rearranging of the elements is called the process of permuting. And yung permutation occurs in more or less prominent ways in almost every area of mathematics. So they often arise when different ordering on certain finite sets are considered. So take note that it is finite, meaning it is countable. While the combination is a way of selecting items from a collection such that this is unlike the permutation. The order of the selection does not matter. So in smaller cases, it is possible to count the number of combinations, which refers to the combination of n things taken k at a time without repetition. To refer to the combination in which repetitions is allowed, the terms k selection or k combination with repetition are often used. So permutation and combination, these are two related things. So permutation, again, for example, we take note of the arrangement and we take note of the sequence, we take note of the ordering. Where in combination, ordering is not considered. So permutation formula is this one. So we have the n factorial divided by n minus r factorial. So a permutation is the choice r things from a set of n things without replacement and where the order matters. So as we have said a while ago, the order matters. So arrangement of the elements is considered. While in combination, as we have mentioned a while ago, the order does not matter. So as you can see here, in the formula of permutation, so we have here n factorial over n minus r factorial. And for combination, we have n factorial over r factorial multiplied by n minus r factorial. So as you can see, in permutation, since ordering is considered and in combination order is not considered, so we make use of r as one of the divisor in combination to delimit the number of possible sets or elements that is considered as part of the combination. To clearly see the difference between permutation and combination, we have here a table in order for us to clearly see its difference. So in permutation, we arrange people, digit, numbers, alphabets, letters, and colors. While in combination, we select menu, food, clothes, subject, and team. So in permutation, we pick team captain, pitcher, shortstop from a group. While in combination, we pick 3 team members from a group, regardless who is the captain, the pitcher, or the shortstop. In permutation, we pick 2 favorite colors in order from a color brochure, while in combination, we pick 2 colors from a color brochure. And in permutation, we pick first, the second, the first, the second, and the third place winners. And in combination, we pick 3 winners. As we have mentioned, in permutation, order is considered, where in combination, the order is not considered. Uses of permutation and combination. A permutation is used for the list of data where the order of data matters, as mentioned a while ago, and the combination is used for a group of data where the order of data doesn't matter. So let's have here an example. Find the number of permutation and combination if n is equal to 12 and r is equal to 2. As a solution, we have the given n is equal to 12 and r is equal to 2. Using the permutation formula, which is n factorial divided by n minus r factorial, we need to substitute the given that we have a while ago. So n is equal to 12. So that's 12 factorial divided by 12 minus 2 factorial, which is equivalent to 12 divided by 10 factorial. So we need to expound 12 factorial, that's 12 times 11 times 10 factorial, in order for us to eliminate 10 factorial as our divisor, and we'll get 132 as our permutation. For combination, obviously it is of lesser value compared to permutation. So our formula is n factorial divided by r factorial multiplied by n minus r factorial. So substituting the given that we have a while ago, so we have 12, that's 12 factorial divided by 2 factorial multiplied by 12 minus 2 factorial. Again, that's 12 factorial divided by 2 factorial multiplied by 12 minus 2 factorial. So we need to get the difference between 12 and 2, so that's 10. So we only have 12 factorial divided by 2 factorial multiplied by 10 factorial. And then expounding 12 factorial to 12 times 11 times 10 factorial in order for us to eliminate our divisor, which is 10 factorial. And what's left to us is 12 times 11, which is equivalent to 132 divided by 2. Since 2 factorial is equivalent to 2 times 1. That's why it is 2. And the answer is 66. As your activity, you can answer example number 2, which is in a dictionary, if all permutations of the letters of the word again are arranged in an order, so how many permutations will we have? Example number 3. In how many ways a committee consisting of 5 men and 3 women can be chosen from 9 men and 12 women? So take note of what we need. So we need to have 5 men and 3 women taken from 9 men and 12 women. As a solution, we need to choose 5 men out of 9 men, that is 9C5 ways, which is equivalent to 126 ways. And we need to choose 6 women out of 12 women, that is 12C3 ways, which is equivalent to 220 ways. And the committee can be chosen in 27,720 because the first thing that we need to consider is how many ways in selecting men, and the second way is selecting women. So we need just to multiply 126 by 220 to get 27,720 ways in selecting 5 men out of 9 men and 3 women out of 12 women. That is permutation and combination.